I really want to start by thanking the RIBA and Wendy and Kurt for putting together this event, which I think is exciting, and I'm really delighted to be here. And they've done a superb job of organizing the event. So we're here to talk about current efforts to preserve digital design records. So to put my remarks in perspective, let's see, no, there we go. Here you see an image of the National Gallery in Washington, and the East Building is that building there, building under construction, the West Building behind it, the Washington Monument beyond. What I'll discuss is based on our experiences in the archives of the National Gallery, but I believe its essential elements are more widely applicable at the same time that, as everyone will say today, there isn't a right answer. There are a lot of different tries at this point. So feel a certain humility in presenting new ideas and looking forward to your comments on them, really. You all are already aware that most architects and design firms work in an environment that's almost entirely digital. Preservation of the important digital materials that they're creating is a critical and immediate problem with extraordinary challenges. Bit streams can degrade over time, hardware wears out, and new, drastically different technologies emerge. Design software changes almost month to month. You know all of this. There's no easy answer, but I do think that there are reasonable strategies to protect and preserve digital data, even now. You'll hear later in the program about some intriguing experiments to permit preservation of interactive data, vector data, multidimensional. They're exciting projects with great possibilities, but they're difficult and technologically demanding at this moment. I'm going to take a different approach and talk instead about a practical framework to preserve digital design records now with current knowledge and tools. I'll begin by placing this effort in the broad context of digital preservation, and then we'll use a case study to show that it's possible in the real world now to care for architectural documents, albeit with costs and limitations. To begin, the so-called OAIS, the Open Archival Information System, provides an overarching conceptual framework for a simple, reliable repository. The OAIS was developed for enormous sets of scientific data, but its conceptual outline works well for historical, archival, and design records. You see here the well-known OAIS functional diagram for compliant digital repository. You can view the framework in various ways, but in essence, it provides a construct that distinguishes life cycle phases of digital objects, separating ingest from storage, from management, from access. Packages of information are brought into archival storage accompanied by external descriptive information or metadata. You can see that. Oops. How do I go backwards? A bit dangerous.
Too quick. Do you want to go back or forwards?
Back. I was trying. There we go. Great. So you see the movement from producer through ingest, the descriptive information or metadata, into archival storage. This is extremely helpful and suggests a comprehensive way to understand the digital objects and preservation. Beyond the OAIS, traditional archival principles are also available to guide organization of an effective repository. Perhaps most important, a digital repository must be understood as an integral part of the larger archival repository to which it belongs. Let me see if they're pushing the right button. I'll illustrate this most obvious point with building photographs, but the same concept applies to any media. Here you can see a digital scan of an original analog 35mm slide. You can see the, oops, did that wrong. You can see the telltale round corners of the original slide. And here you see a similar born digital view. Adding in the original slide, there are at least 3 versions of closely related images, different, but all managed by the same archival description software and of potential interest for comparable purposes. Evidently, even as record-keeping practices evolve inevitably toward digital media, it's important to relate digital files to the entirety of the repository, and the relationships between materials in multiple formats must be self-evident. There are a few other concerns that must be constantly present in building a digital repository. First, as the OAIS diagram makes clear, digital repositories must be managed by external systems for capturing and presenting comprehensive descriptive metadata. Most repositories already have such a system. In our case, it's the purpose-built relational database called the Description Master. Here you see the home screen. And here's the primary search screen that allows investigation by source, subject, building project, media, and other search criteria. Following archival principles, it works equally well for records in traditional formats and for digital media, which are assigned to different archival series. Following the OAIS model, this allows us to securely capture and permanently retain external information about every digital object in the repository. Another important governing concept has been to avoid proprietary and undocumented software in repository management. Thus, there's been a strong preference for working directly with digital objects on the server. This is a screenshot showing the organization at the repository at the highest level, simply folders in a hierarchical structure without intervening software. And here's a slide showing the organization of the permanent archive section of the repository at the next level, organized by record group and series. Looks a lot like a traditional archival repository. And here's a screenshot at the next level. Another concept has been to limit file formats to a minimum of open, documented, and widely used formats, such as TIFF, JPEG, PDF. There will be others over time. Any proprietary or unusual formats or vector files that depend on original software are generally converted to widely used raster formats, such as TIFF, as you see here. That's what all these images are. We realize that in doing this, we may lose functionality and insight into the architect's work, but it's a compromise that we believe we're forced to make at this time in the interest of securely preserving essential data for the next decades. The slide also illustrates another point. To ensure that the repository is robust and easily understood without software intervention, digital objects or groups of digital files are assigned digital names based on a controlled, extensible naming convention that can be applied universally to all materials, digital or analog, whatever their source or form. And of course, it's these names that make possible the links between analog originals, digital copies of analog originals, and born digital materials, that unifying concept behind the repository. The names are unique, consistent, and meaningful, and best of all, they fall naturally in a clear hierarchical structure, so that if anything goes amiss, you see that there's a problem within the hierarchical structure. To explain a little bit more, in brief, the first segment of the digital name, in this case 26, oops, I didn't mean to do that. The 26A4 is for the archival series that designates the source and format of the object, in this case evidently digital. The second element is a link to the database with its rich metadata, the _31502. And the third element is either a sequential number, as you see here, or an original meaningful designation provided by the record's creator. Using this system, digital objects can be instantly recognized and tied to their source and subject. Because of their consistency, digital names can be used to find a group of related materials with remarkable ease, and the names themselves can be easily changed using automated systems and simple rules. And so should conversion be necessary, as we anticipate that over the life of the repository will happen, it can be an automated process because of this extreme rigidity. Of equal importance, the organization of the larger repository built on these digital names is meaningful and self-evident, and mistakes, which are inevitable, can be recognized and corrected. As an aside, even with this tight structure, security is a critical element of repository management, so I'll mention it here. Digital data is subject to catastrophic failure, and assuring its long-time safety is possibly the most important aspect of the repository. We're not technologists, and we depend on IT staff to secure the data against bitstream and digital failure. Not always entirely successfully, I have to admit, but whatever. So our responsibility as professional archivists, in my case, is to protect against human error to the greatest extent possible. At this time, honestly, software and server tools really don't support us convincingly in this, but at minimum, access levels need to be defined and monitored, and the policies that we've developed that we find are most successful is to require teams, pairs, to work together, looking over each other's shoulders when the buttons are pushed to make sure that things go right. Constant vigilance is an essential element of digital repository management. So returning to the slide about the basic repository structure, it's really based on 6 server folders that manage the digital workflow and are the core of the preservation of the archival materials. Although each folder is hierarchically equivalent on the server, they have significantly different functions within the repository. Here you see the repository folders, which we actually call sectors, but they're in a workflow view. As you can see, the process begins in Sector 1, a shared network folder where digital objects are deposited with the original digital names and folder structure intact. This can be from an internal structure or source, or it can also be external. And if we're importing from removable media, there's an intervening layer of checking and security before adding it to the server. But from our point of view, ingest through this folder ensures parallel management in every case. Typically, though, the ingest is internal for us. As an example, once a month, staff in the architecture and engineering department open the shared folder and place in it contractor progress photos and videos. This transfer constitutes the submission information packet, or SIP, in the OAIS context. Archival staff then examine the digital files in the ingest folder and appraise their long-term value. If everything is in order and if the records are determined to be appropriate for preservation, an important part of the process, the archives assumes physical possession and ownership of the files and creates a record of the transfer in the archive's relational database, following procedures that we use for records, whatever they are. So here's the ingest screen, the records transfer screen. From this point, the acquisition is identified by the database assigned transfer ID number, which is up there. They're moved intact. This is a view of what we call Sector 2, the archive's working space. The files are moved intact to Sector 2, and they're also copied to a multi-disk RAID-protected external hard drive, a dark archive to be used only in the event of catastrophic digital or human failure. So back to the workplace view. In Sector 2, the working place, digital objects can be stored indefinitely, awaiting processing. And within the space, they also can be manipulated and transformed into their final preservation form without confusion. Here you see the folder structure of a group of records at the time of ingest. Our experience has been that actually before digital files are transferred to us, generally there's an awareness of the need to put some kind of organization on them. In other words, people are actually more careful, not less, although that clearly also can be entirely the opposite when you get removable media that's just in the bottom drawer. That's entirely the opposite. But I think there is cause for hope that people who are creating and using digital files actually themselves have to find them, and that has helped us enormously. Nonetheless, we do get files with completely disorganized and misspelled names, everything. Whatever condition we find during we process the materials, open and flatten the digital, whatever digital structure it is we find, and we rationalize the digital objects. The folders are renamed using that naming convention I mentioned, and this is really the heart of the ingest process. And of course, it actually is fundamentally parallel to traditional archival processing. At this point, the important thing to realize is that there are lots of ways to do this ingest, this processing. So the real point is what the goal is, where we go to with it. But there are off-the-shelf tools, and our key off-the-shelf utilities at this moment that we use to do this are simply Adobe Bridge, Rename It, and Excel spreadsheets. Those are our workhorses. But systems will change over time. It doesn't matter. The point is that what you end up with, the product, is simple and stable. Okay, returning to the workflow again, it's important to emphasize that even a simple model like this offers a lot of flexibility. Talking about the multiple forms that digital objects come in, and this is a point that Alex makes in his report, and Ines also, that there are reasons to keep the same information in multiple forms, and the repository structure needs to be organized in a way to manage that. So typically we do get digital materials in a single form, but often we do get them in multiple forms. And so the way that we manage this is, again, with these hierarchical folders. An example that's pretty typical for us is that a photographer transfers images both as camera raw files and in processed TIFF form. Or we often get digital scans of text where we can get a searchable PDF that's used for access, but also a native TIFF image. We want to keep both of them. In those two examples, one of the versions is, in essence, an access version. The first case, TIFF, and in the second case, the PDF. And the second format, and it can be the second and the third and the fourth formats, they're needed for preservation, but not necessarily for immediate access. So to manage this, the digital archival repository includes a sector called the sector called the preservation archives. Simply a folder, but it's a different way to manage materials. These are controlled at the digital folder level by the same systems that are used for the archival sectors and comparable metadata, but the individual digital objects are not renamed. There's also a records center here, which is important because we find that when people transfer digital objects to us, even if we decide that they lack sufficient value for long-term access, we're not free just to throw them away. There are relations with the creating office, the donor, but we can move them using the transfer number plus the records series into the, into the records center sector. Our example, which is not, it's not digital design, but it sort of illustrates the point, is that we get all of the photographs taken at annual Christmas parties of, staff sitting on Santa Claus's knee. And, we work so hard to get people to cooperate with us. We don't want to say, well, maybe not. So we keep them temporarily, but we put them in the records center. There's also, as you can see, a reference sector where we put other things that should be kept. Let's see, that's right there. But you see it's unrelated to the ingest process. So here you see the OAIS diagram again. In keeping with the OAIS OAIS concept of the Dissemination Information Package, or DIP, the format or size of digital objects may be changed on the fly from that archives sector for delivery to users, but the essential object and key descriptive metadata are maintained so that the meaning and context of the digital objects are always clear, and of course the retained digital object remains untouched. So turning to how does this work in practice? We're all at the beginning of working day to day with architects in the electronic environment, but we have had pretty intense recent experience. Let me describe this experience. It was records created for the National Gallery's East Building exterior stone repairs project, which you see underway here. Many of you may be familiar with this project, which has been dramatically visible on Washington's skyline for the last several years. In essence, the East Building, which was designed by I.M. Pei, is a freestanding brick and concrete structure clad with 3-inch thick panels of the same Tennessee marble that was used for the original West Building. So here you see an original construction slide made during 1974. The marble blocks for the original building were thick enough to be self-supporting, but the 3-inch panels for the new building were hung on the underlying brick and concrete structure using a technologically innovative system of anchors, which sadly began to fail over time. They didn't work real well. So to prevent stones from falling, it has been necessary to remove every marble block and rehang it using a newly designed and more stable system. This was a massive task. From the archival point of view, the important point about this project has been that it's very large, that a gigantic amount of information has been created, and that for the first time at the National Gallery anyway, the data has been entirely electronic. During the project, building records were largely lodged in 2 proprietary data management systems. One of these, the Vela system, was specifically designed to photograph, inventory, measure, and track each of the thousands of stones that were removed, cleaned, and eventually restored to the building. Here you see a few of the thousands of stone and anchor images. Not great works of art, but important as buildings records for the future. This is an inventory form where every stone was measured and recorded. The Vela reports and images are precisely organized and tied to a key plan, so there's little concern about locating or understanding the documents. And we were delighted to learn, as an afterthought, I sadly admit, that the system is capable of downloading the documents, but at a charge. So I would suggest being aware of that when systems are selected for projects. We had few choices about the format for the downloading of the documents, and they were in fact all standard formats, and we selected PDF-A, the archival flavor of PDF, which has features and requirements that are supposed to promote long-term preservation. Unfortunately though, as many of you know, although published, PDF is still a proprietary format of Adobe, and it also comes in multiple evolving versions. So nothing is as simple in the digital world as first meets the eye. Nonetheless, we did conclude that PDF-A is the best available preservation option at the moment, and we're saving all of the Vela images in the form of composite PDF-A documents. Given the uniform form and transparent organization of the documents, we've decided to import the Vela PDF-A documents into the archives as closed document packages, which though very large are intellectually extremely simple, as we expect that this data will be needed only rarely. We're also looking into keeping this very large data set offline or nearline in a data center and also for managing it with our archival database. So far the process seems to be working. So here's another example. Vela is a highly specialized software which we don't ever expect to encounter again. On the other hand, eBuilder, the other digital management software used for the project, or its equivalents, are likely to be regularly used in the future. In essence, eBuilder is a cloud-based records management system that allows access to shared documents between the client, architects, engineers, and construction contractors. It was the bread and butter that made this project work. The many players and steps in the design and construction process remained the same, but the electronic system made it possible to closely track design, submittals, drawings, and all the other multiple documents that make up the project across geographically divided locations. Although graphic documents entirely are,
5 minutes.
5 minutes, good. I'm almost through. Although graphic documents are almost entirely created with complex CAD software, in fact, the system requires that all the documents be saved and transmitted in standard PDF form. So there's no question of complex vector or unusual formats. Nonetheless, the documents still need to be extracted from eBuilder, which is, after all, proprietary and fee-based, so we need to get out of there as soon as possible. You were looking at a shop drawing as it was extracted from eBuilder, created by CAD, viewed and approved as a PDF. Oops. And here, this is a server view of named PDFs downloaded from the system. Fortunately, the construction contractor was required to provide documents as a project deliverable, and in fact, they were hugely relieved that we told them that electronic was the preferred version. They actually were prepared to print out the thousands and thousands of documents, so they were quite happy to work with us on our naming conventions. And so far, the results are encouraging, and in fact, many of the problems that we were fearful of, weird formats, illogical or unorganized files, it just didn't happen. In fact, the eBuilder forces disorganized people to be extremely organized. So we are hoping, though cautiously, that in the end, born digital records may even be easier to take care of, despite very large startup costs. So that's good news. Yet, of course, significant challenges remain. And the blending of intellectual and automated processes for repository remains complex, and greater automation is needed to manage the ever-increasing volume of digital transfers. Appraisal is still critical, and we need direct relationships with record management systems. Another problem, of course, is that architect sketches and other ephemeral documents may be excluded from project management environment. So you hear one of IMPA's early sketches for the East Building. But the fortunate thing is that within the context of the broader archival repository, we can preserve digital sketches when they're offloaded in a consistent and simplified format. So here in closing, I'm going to show you one of the beautiful digital views of the National Gallery of Art that are now securely preserved in the museum's digital archives and will continue to be for the foreseeable future. So built on the OAIS structure and archival principles, the digital repository is functioning now, and we hope provides a flexible, resilient structure for future growth. Despite all challenges, the goals are essential and rewarding, and in the end, we have no choice but to go down some path like this. Thank you very much.